Hello students and welcome back to For Knowledge once again. How are you doing? In today's session we are going to discuss about polar form of complex number. Let us take a complex number z equal to x plus iy. Now this complex number or for say any complex number can be represented in a two-dimensional plane. That is different from a Cartesian plane. Cartesian plane means where you can represent a point in a two dimension. Okay, but this complex number, if you want to represent it in a plane, there you need a special type of plane. Okay, that plane is called Gaussian plane or Argand plane or complex plane. Okay, Gaussian plane or Argand plane or complex plane. Suppose this is the plane, this is the real axis and this is the imaginary axis with this being the origin. Okay, now you can represent the complex number in this plane. This is the Gaussian plane or Argand plane. How? Think of like this is the real part, this is the imaginary part. Okay, so just like in Cartesian plane, what you do, just do the same thing here. That means from the origin, from the imaginary axis, move along the real axis, we'll get the x value. That means suppose this is x. Okay, this is the x comma 0 point. And suppose from what is y? Suppose you are moving starting from origin and moving along the imaginary axis. This is the 0 comma y. Okay. Now where these 2 points, where these two straight lines meet, this is the x plus iy point. This is the point P, which is x plus iy. Or you can write this as x comma y. Okay, where x is the real part of the number, y is the imaginary part of the complex number, and this is the Gaussian plane. Okay, so now look. Now we can represent this in a different manner. How? Let us consider, let us join this O and P. Let us join this O and P. Okay. So this OP will create an angle, suppose theta, with the positive direction of x-axis. X-axis means the real axis. Okay, and this is the imaginary or y-axis. Okay. So this OP is creating an angle theta with the positive direction of x-axis. Here, using this OP distance and this angle theta, we can represent the complex number in a different form, which is called as the polar form. Okay. So initially we are starting with x plus iy, that means xy in the Gaussian plane, and we are trying to move the representation from xy to this OP distance and this angle theta. That is what we are trying to do here. Okay. So what is OP? What is the distance OP? We represent it by r. The distance OP we represent it by r. Now what is OP? Very simple. Very simple. Just draw a perpendicular. Just draw a perpendicular on the x comma 0 point from the point P. So what is this happening? This is nothing but a right angle triangle. This is nothing but a right angle triangle with OP being the hypotenuse and this x being the base of the triangle and this being the height or altitude of the triangle. So basically in this triangle, these x and y are the two sides, two adjacent sides to the right angle, and OP is the hypotenuse. So basically OP is nothing but r, which is denoted by r, is nothing but root under x square plus y square. Very simple. Right? Very simple. Now, how do we find the theta? How do we find the theta? So basically, how do we use theta? Not find. We'll come to the find part later. How do we use theta to remove this x and y? Look, we know the r and we have the theta, right? So we have to change the x and y to r and theta. We have to change the x and y to r and theta. So what if we try to introduce the trigonometric ratios in this format? How? Look, in this right angle triangle, that is POQ, suppose this point is Q. In this right angle triangle POQ, consider OQ. OQ is nothing but the base of the triangle, and divide it by OP. Divide it by OP. So this is nothing but x by r. What is OQ? OQ is nothing but x distance. And what is OP? OP is r. Now in a right angle triangle, what is base by hypotenuse? This is nothing but cos theta. This is nothing but cos theta. So very simple. So x is nothing but r cos theta. We have replaced x successfully. Now how do we replace the y? Very simple. Look, similar manner. QP. QP is the height or altitude. So QP divided by OP. What is OP? OP is the hypotenuse of the triangle. This is nothing but y upon r. This is sine theta. Why sine theta? Because altitude by hypotenuse. Okay. So this is nothing but y equal to r sine theta. So we are successfully replacing x and y. So what is the representation of z now? Z was x plus iy. So this is nothing but x is r cos theta plus I times r sin theta. So take the r common. So r cos theta plus I sin theta. This is a new representation for a z using the r, that means the OP distance, and the theta, that is creating that OP is creating with the positive direction of x-axis. Okay. This form for z is called the polar representation of the complex number. This form is called the polar representation or polar form of the complex number. Okay, where r is nothing but the modulus of the complex number. Modulus means the distance of the point from the origin in the argand plane, and the theta is called the argument of the complex number. Theta is called the argument of the complex number. Now, the r is always positive because it is representing a distance. So r is always positive. But there are a lot of things to know about the theta. Theta is nothing but the amplitude or argument. R is the modulus of the complex number, and the formula is root under x square plus y square, and theta is the argument of the complex number. In this video, now we are going to discuss about this quantity argument. How do we find it? Okay, how do we find argument given a complex number in this form? Fine. So if this is clear, let's clear this part and move on to the argument part. Shall I erase this? Hope so. Now I'll write this image, I'll draw this image once again. Suppose z equal to x plus iy, and this is P, which is nothing but x plus iy. X plus iy means x comma y. This is origin. This is Q. This point is x comma 0. This point is 0 comma y. Okay, and this angle is theta. Okay, Now we are going to discuss about theta, the argument. Now for any complex number, we will be having an argument. Okay, what is argument? Argument means if you join the origin, that means O, to the complex number, then the angle that is made up with the positive direction of x-axis, that is called the argument. That means suppose this is in the first quadrant. Suppose, let me draw again. Suppose the point is here. So if we join O and P, then this angle is the argument, like that. Okay, positive direction of x-axis, the angle that is being formed, that is the argument. Okay, this is the theta. But the problem is here that in case of this diagram, suppose this is the point P, this is the angle theta. Okay, this is the angle theta. Now we can think of like that. We are starting the we can start the calculating angle here from here, and we are making a full revolution of 2 pi, and then we end up here. So what will be the angle? Now the angle is theta plus 2 pi. Are you getting my point? It can be theta. Again, if we complete a complete revolution, that is full revolution, that is the angle of 2 pi, then once again we are reaching here, and the angle is theta plus 2 pi. So this can also be the argument. We cannot deny that, because what is argument? Argument is nothing but what the angle is made with the positive direction of x-axis. That's it. Okay. So the argument can be theta, argument can be theta plus 2 pi, argument can be theta plus 4 pi. So how do we encounter this problem? So to encounter this problem, we have introduced the concept of principal argument or amplitude. We have introduced new concept, principal argument or amplitude. What does this mean? It means we are restricting the value of theta to some extent. Okay, so that we cannot keep on increasing the value of theta like that. Okay, or not the value of theta, value of argument like that. Like theta first, then theta plus 2 pi, then theta plus 4 pi, 2 revolutions. Like keep on increasing, we want to stop them. For that, we are restricting the value of theta to some extent. What is the restriction? The restriction is we start from minus pi, and the principal argument will be in between minus pi to pi, so that it does not keep on increasing like that. Okay. So this is the principal argument or amplitude of the complex number. Now, how do we calculate it? This is the range of the principal argument. This is the range. Now, how do we calculate for separate complex numbers? Suppose we were given one or two complex numbers. Then how do we calculate this? How do we calculate what is the value of theta? Okay. We have restricted it, but we don't know yet what is the value of theta. That's what we need to find. So I hope the principal argument part is clear. In order to restrict the value of argument, in order to keep it still, that's why we are restricting the principal value branch. Okay, that's why we are restricting to principal value branch for the argument, which is called principal argument or amplitude. Let's move on to the calculation part. Okay, how do we calculate? I am going to give you a simple algorithm for that. How do we proceed? Let's see. First, what you need to do is to identify in which quadrant the complex number is lying. Okay. You need to understand in which quadrant the complex number is lying. That means from the given number x plus iy with the sign of x and y. That means whether x is plus, y is plus, x is minus, y is plus, or x is minus, y is negative, and x positive, y negative. Based on this sign criteria, we need to first categorize the complex number into the quadrants. That means which quadrant it is lying. So, sign and quadrant. If x and y both positive, then of course the complex number lying in the first quadrant. Both of them are positive, x and y. If x is negative and y positive, then the complex number is lying in second quadrant. Because in second quadrant the x value is negative but y value is positive. If both of them are negative, then it is in third quadrant, and finally if x positive and y negative, then it is in fourth quadrant. This is the first thing you need to do. First thing you need to do. Step 1. Now step 2. What is step 2? In step 2, you need to find an alpha angle. How? Using tan inverse mod y by mod x. Why the modulus? Beg your pardon. Why the modulus value? So that we can restrict the value of alpha in first quadrant. Because in first quadrant everything is positive. Okay, everything is positive. So we want to restrict the value of alpha in first quadrant. That's why we are taking the inverse of tan in with mod y by mod x. Okay, so we are getting an alpha using this formula, tan inverse mod y by mod x. Okay. Now comes the step 3 and the most important step. This is quadrant. This is the quadrant. And this side the amplitude of z. Okay. If z is in first quadrant, that means if both of them are positive, then amplitude of z, that is theta. That is theta. Amplitude of z, that is theta, is nothing but alpha. This theta is nothing but alpha. As simple as that. Okay. If it is in second quadrant, then theta becomes pi minus alpha. Theta becomes pi minus alpha. If it is in third quadrant, here it comes a little bit tricky. Since what we have told the principal argument lies in between minus pi to pi. Minus pi excluding, pi is including. So in the third quadrant, when it is coming to third quadrant, the theta will nothing but minus of pi minus alpha. That means we are starting from minus pi, in between minus pi by 2. Okay, minus of pi minus alpha. And for fourth quadrant, how do we get this? Using this sign technique. For fourth quadrant, the theta will be nothing but minus alpha. This is the three simple steps to find the principal argument or amplitude of a given complex number z. These are the three simple steps you need to follow. First, you need to find out the quadrant where the z is lying. Second, you need to calculate the alpha, tan inverse mod y by mod x. And third, you have to follow this table and get the result. That's how we find the amplitude of z. Now we are going to take one example, how to find the amplitude, as well as we will see how we convert the given complex number into the polar form. If you are done with this, then I am going to erase the part. we are taking with a very simple example, and I'll leave some examples for you to solve. Convert z equal to 1 minus I into polar form. This is the x plus iy form. Okay. So what is x? X is nothing but 1. And what is y? Y is nothing but minus 1. Right? Now we need to find first the modulus. Because in the polar form we need to convert it into polar form. So in case of polar form, we need the modulus as well as amplitude. First we calculate the modulus. So mod of z, that is the r, is nothing but root under x square plus y square, root under 1 square plus minus 1 square equal to root 2. Okay, modulus is root 2. So for the first part, that is what were our polar form, z equal to r into cos theta plus I sin theta. This was the polar form. For this, we have already found out what is r. R is nothing but root 2. The only leftover part is theta. We need to calculate the theta. So now let's go for theta. Tell me which quadrant is it lying? X is positive, y is negative. X is positive, y is negative. That means z is in fourth quadrant. Z is in fourth quadrant. First step 1 for calculating theta. Okay, z is in fourth quadrant. Second step, we need to calculate alpha. Alpha equal to tan inverse mod y by mod x. So tan inverse mod y means mod of minus 1, that is 1 by 1. So tan inverse 1. Now tell me for which value of alpha, basically alpha is tan inverse 1 means we can write tan alpha equal to 1. Alpha is tan inverse 1 means we can write tan alpha equal to 1. Then for which value of alpha tan becomes 1? In case of a acute angle, alpha is in acute angle because it is in first quadrant. First quadrant means angle in between 0 to pi by 2. So in between 0 to pi by 2, for which angle tan alpha becomes 1? Obvious, it is 45 degree. Obviously alpha equal to pi by 4, 45 degree. So this is nothing but pi by 4. This is the second step. We are done with that. Now number 3. In which quadrant is it lying? It is lying in fourth quadrant. So go to the previous table. In case of fourth quadrant, what is the value of theta? Theta is nothing but minus of alpha, that means minus pi by 4. Okay? Theta being the amplitude or principal argument of z. Okay? So now we already have r, and now we have the theta also. So the polar form is nothing but z equal to r, that is root 2 into cos. Allow me to use the third bracket. So cos of theta, cos of minus pi by 4 plus I sin theta, that is I sin minus pi by 4. This is nothing but root 2. Cos of minus theta is nothing but cos theta. Sin of minus theta is minus sin theta. This is the polar form for z. This is the polar form for z. Got it? Simple. Just look at the complex number. Understand in which quadrant it is lying. Here I have identified it as fourth quadrant. Now once you get the fourth quadrant, then calculate the angle in terms of first quadrant, that means mod y by mod x. We are getting as pi by 4 alpha, and follow the table. That means if the complex number is in fourth quadrant, then theta is nothing but minus alpha. So this is minus pi over 4. So now put it in this form, which is the polar form for the z. Z is nothing but root 2 times cos of theta plus I sin theta, that is cos pi by 4 minus I sin pi by 4. That's how we solve the problem. Now I am giving you some assignments. Shall I erase this? Convert complex numbers into polar form. Number 1, z is 1 plus root 3i. Number 2, z is minus 1 plus root 3i. Minus 1 minus root 3i. 1 minus root 3i. You have to convert these 4 complex numbers into polar form. That is your assignment. Okay. So first you need to find the modulus and then go for the principal argument. Okay. So I hope the episode is useful for you. You will understand the topic. I tried to make you understand very easily, but still if you have any doubt, any complaint with it, please let us know. Please subscribe the channel. And let us know in the comment. We will be meeting very soon. Thank you.